Alright, hell yeah. So today what we're going to find is the distance between two parallel lines, and we're going to try to do it with some intuition. The main take-home point that we'll get from this video is how to treat slope as a fraction, where we have fractional components compared to a hypotenuse. So sweet. And I'm going to show you how you can do this in, under a minute. So I'm going to write and this is the y-intercept form. It's not the matrix form, it's just the y-intercept form. So I have a line that's y1 is equal to the slope. Now the slope of both these lines are going to be the same, x1. And when they use matrix form, for this should just be like y is equal to mx plus b. But in a lot of text, because you use linear equations in matrix form, you're going to have this constant. B is just this is going to be a C1. So that's what I was trying to get at. Alright, so now you got y2 is equal to same slope, because we're trying to find the distance between two similar lines. And then we have x2 plus c2. Okay, so now let's draw just a quick sketch. So what's going to happen with these two parallel lines is they're going to hit the y-intercept probably at two different places. Well, obviously, because we're trying to find the distance between them. Alright, so that means that the distance is going to be a perpendicular distance, and so we have a right triangle, and guess what? We have a hypotenuse here. So this is the hypotenuse, and it's just going to be the difference between these two numbers. And you might get a negative, so in the equation, they just do absolute value. So I'm going to say if this is the hypotenuse h, we're going to have h as the absolute value. And then even in the text, they just go C1 minus C2. Since you're taking an absolute value, there's no reason to take the second one subtracted by the first one. So that's how you kind of see it on the internet or whatever. And hell yeah, but we're interested in this distance. So, we'll go over this kind of slowly. But the take-home point is like, hey, can we do this all in one go? Because I do know the slope of this line. So I'm going to come in here. The slope is rise over run. So we have m, that's our slope, and 1. You know what I mean? So, hell yeah. So slope is going to be rise over run. And if we do a run of 1, this number is our slope. You know what I mean? So that's kind of what we see right there. Alright. Now, it's not too tricky. But how to do this in one step. Let's just do it in one step, and then we'll slow down, and we'll see how to take this triangle, find the hypotenuse. So that's kind of what we're doing. If this side of this, what you're doing is you're making a mini right triangle. You know what I mean? It's proportional to this bigger triangle. So that's sweet. And so if these are your two sides, your hypotenuse is going to be the square root m squared plus 1. And the whole idea is get your hypotenuse equal to 1. So we're going to divide this triangle by the square root of m squared plus 1. So now we have our hypotenuse is 1. Now we can multiply that hypotenuse just by the, this is now a unit, a triangle with a hypotenuse of 1, kind of a unit triangle. And we have a hypotenuse of h. So we can just multiply this whole triangle by h. And when we do so, we know the sides of its components. So if this is hypotenuse, now we know this side. You know what I mean? It's going to be this equation, h divided by the square root m squared plus 1. So let's see if we could have done that in one go, on our little card. So I'm trying to find this distance. I know just by visualizing this, if I take my hypotenuse to 1, I'm going to divide by this hypotenuse, which is the square root of these two components squared, m squared plus 1. And then I'm going to take this dimension and multiply it by the actual hypotenuse. And then I'm going to say, hey, that's d. So that's how I would do it kind of fast. And so now we have distance d is this hypotenuse, which is c1 minus c2, divided by the square root of m squared plus 1. Alright, that wasn't too fast, but now what we're going to do is go over it just a little bit slower. And, I even did like a cutout because Alright, sorry about that. Yeah, so I made a cutout, and I made the kind of the triangle a little bit narrower, so that'll be able to definitely see the two sides. You have a hypotenuse, and then maybe a longer side and a shorter side. But these two sides of a right triangle are always shorter than the hypotenuse. Okay, so now we're going to go through it a little bit slower. So we're going to have two lines that are parallel. This equation is y1 is equal to mx, y is equal to mx plus b. I just threw a subscript on 1. Y is equal to mx plus b. Just subscript of 2, saying that this is line 2, this is line 1. Now when they're parallel, the slopes are the same. And then both go through the y-intercept. And we know where they go through the y-intercept because, if this is an x, y coordinate system where we have y and x, when x is 0, so if I throw in 0 to this equation, this becomes 0, 0 to this equation, then I get just y1 is equal to b1 and y2 is equal to b2. So that's what we have right here. When x is 0, this is the b1. When x is 0 on equation 2, this is b2. Cool. And then another way to, in the text they use absolute values. They're just going to take, like I said, c1 minus c2, absolute value of it. In this, I just got in the habit of taking the second minus the first. So the absolute value, if I take this minus that and the absolute value of it, is the same thing as, taking b2 minus b1, squaring it, and then taking the square root. It's the same as having, like, in the x direction 2, in the y direction 1, and then you're like, hey, what's this distance? Well, the distance is going to be, 2 points. This is 0, 0. This is 2, 1. And so the distance is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. Just in our problem, if you're just trying to find the distance between a straight line or a perpendicular, a vertical or a horizontal line on an xy, one of these is just 0. So, like, hey, our x values are just 0, so we just get the difference between the y values. But if you square it and take the square root of it, it gives you that absolute value. I guess that's all I'm saying. Alright, booyah. Alright, now for the secret sauce of this video is, hell yeah, I definitely see that this is the slope. I swear I graduated with not knowing, how to do this method. You're just like, hey, if this is the rise, the run is just going to be 1, And again, if slope is rise over run, and I set my run to a unit length of 1, then my rise has to be m. You know what I mean? So see this relationship? If my slope is some number m, and I'm going over 1, then I must have to go up, this value of m. So the value I put on the slope is equal to this number divided by 1. Cool. And then even if you get a slope, if you get a slope of 2, there's a lot of, like, this happens all the time. It's just like, if this fits the bill, just turn it into a ratio right off the bat. So if I see a slope of 2, if I see a slope of 3, I'm going to say that's 3 divided by 1. Because slope is a ratio between rise to run, and then it can spell out what that run is. Cool. And now we just use Pythagorean's theorem, which can get overlooked a lot. Where we have, if I square this and add it to the square of this, that's going to equal the square of the hypotenuse. And probably the simplest thing to do is solve for the hypotenuse. So we're just going to, it's the square root of a squared plus b squared. And even that, I don't know, I would just lose my mind in college, and I don't think I would want to do that or ever do that. Or no professor was going to take the time to slow down and teach that 1,000 times just so you get into the habit, because this is such a useful tool, and we'll see why. Cool. But we need to know how to manipulate this, because if you get this far, it still might, not make a whole lot of sense. But now what we want to do is, I think it's useful to turn this also, just in the various forms that you can turn it into. And if this problem was one where I knew like this length, let's say I knew this length, we have HD, and let's say this length, what variable should we have on this? Let's say this length was E, from there to there. Well, that's going to change my perspective on finding this length. If I know what E is, maybe I'm going to turn this side into a unit. So let's actually do that, just because it's a different problem. So yeah, so let's say I know E is some number, and I know that number. Cool. And then I'm wanting to, and I know what the slope is. The slope, for this case, is just m. It's a variable, but we do know it. All right, hell yeah. And I still want to find what this distance d is. So I have this ratio. What I would do is draw my little triangle and get this side as a function of 1. So with any sort of triangle, I can multiply all sides by a number, and I can divide all sides by a number. That's just going to scale up the triangle. I can't multiply this by 2 and this by 2 and not multiply this by 2. I would have a different triangle. So triangles can scale in that way. So that's kind of the take-home point there. So I'm gonna take this side and go m divided by m. Cool, that's going to be 1. And then this is I'm going to divide all sides of this triangle by m. So I have 1 divided by m, and I have the square root m squared plus 1 divided by m. Cool. So now I have this triangle. Now what I'm going to do is take, I don't know why I drew it a different shape, but now I'm going to, because I know this side is going to be E, you know what I mean? Like this is a triangle that would have the same proportion. If I multiplied this side now by E, I would have to multiply every side by E. So that's kind of the take-home point of what we're doing. So sweet. So now I'm going to say this side is E, and now this side is E divided by M. This hypotenuse is E square root M squared plus 1 divided by M. And now if I was interested in just the length of this side, which would be D, there you go. So D is equal to E divided by M. All right, so that was good just to do a different problem. And had we known something about this length, you know what I mean? And we could have still found the distance. All right, so sweet. So let's go through from here. Since we don't know this length, we do know the hypotenuse. So we're going to say, we're going to do that same thing. We're going to get this triangle, the hypotenuse equal to 1. So we're going to divide. So we're going from here to here to here. And so we divide everything by this square root m squared plus 1. What that does is get the hypotenuse to equal 1. It gets this side to equal m divided by the square root of m squared plus 1. And this side, it gets this side to equal 1 divided by m squared plus 1. So going from here, divide everything by that square root m squared plus 1. You know what I mean? I'm going to divide by that square root, so that's where we see those. All right. Hell yeah. So this is a triangle that would be proportional. It's proportional to this triangle right here. And this right here is kind of the distance I would want. But we need to make the hypotenuse, instead of 1, we need to make it h. So we're going to take this triangle and multiply everything by that hypotenuse h. So that's what we do from this step to this step. Cool. Now we get this triangle with hypotenuse h, and then I know it's 2 sides. Alright, I'm going to interject because it's just like, is there an easier way? You know what I mean? Like, one way to look at this is just like, hey, if I know this is a triangle that can be multiplied or divided by anything, let's just do it right off the bat. Let's just multiply this whole triangle right off the bat by h. You know what I mean? So if I take this hypotenuse and say, hey, this is going to be h square root m squared plus 1, m times h, and then 1 times h. Well, that gives me, this hypotenuse is more, you know what I mean? But from there I could be like, okay, I'm going to multiply this whole triangle by h, But then if I want to get this side, I would have to divide by the square root of m squared plus 1. That would give me this length to be just h, and then this would be h divided by the square root of m squared plus 1. But if it's your first rodeo, as is mine, you know what I mean, I'm going to go through this whole process. I'm going to quickly get this ratio. You know, if I have m and 1, hey, I can definitely see this is the square root of m squared plus 1 squared. And that's the other thing. It's like, hey, well, what's this 1 all about? This is 1 squared. A lot of texts won't, they're not going to put that square in there. So sorry if I didn't do that. But hell yeah, this is m squared plus 1 squared. 1 squared is just 1. And then the square root of that is that hypotenuse. All right, sweet. So so once we got down here where we get our triangle, you know, now our triangle has a hypotenuse of h, and then this side is h divided by the square root of m squared plus 1. So that is going to be that side of that triangle, and that's going to be equal to our distance d. All right, hell yeah. That didn't seem very clear at all, but I don't know. I think it was pretty decent. So, but yeah, that's about it. Once you know that distance d, and we know it in terms of the hypotenuse, and then the square root of the slope plus 1, and then we just go back and be like, what's the hypotenuse? Well, that's just the difference between the slope-intercepts, b1 and b2. I'm going to write it as, you know, kind of in this form. So that hypotenuse is the b squared minus b1 squared square root. So that's how I'm going to write the distance between two lines. I'm going to be like, hell yeah, it's the absolute, this is the absolute, kind of one way to do the absolute value. B squared minus b1 squared square root. And then we're going to divide it by the square root of m squared plus 1. Cool. And again, this is how you're going to see it in the literature for the y-intercept form. You're going to have these constants, c1 and c2. That's going to be my b1. This is going to be my b2. So just know that. Because even that, you know, you don't do this for a year and then you go look this up. You're like, what? You know, what do these even mean? So this is a fun one to derive. I enjoyed it. And I guess we're going to end with showing how, you know what I mean, I can get the slope of this. And then, so check this out. This is such a cool thing. You know what I mean? We have a right triangle. So this is our hypotenuse. These are our two sides. And what I'm going to do is I'm just going to flip it right here. Just so it's just like this. So it's kind of how you would see it. If this is a vertical and this is the horizontal axes, you know, these are the components of the right triangle. When a right triangle is like this, when one of your sides is askew, and then your hypotenuse is on a vertical or horizontal, I don't know, it just makes your mind melt. So it's just, and what I'm showing here is that this slope doesn't change. I can take this triangle and then just flip it right here, and now I can draw it like I have over here. And sorry I didn't even do that at the beginning, but that's what we do in this first step. Is like, hey, I'm going to take this triangle that doesn't look how I like it, and then we're going to flip it, you know what I mean? Just so it's just like, okay, hell yeah, I think I can work with that. And then even going into making this video, I was just like, well, you know what I mean? Let's take that original triangle, you know what I mean, like over here, and then flip it. So that's what we do down here. We get it, but it's still like vertical, and so even that is kind of a pain for me. I kind of maybe want it horizontal. So what we're going to do is say, hey, the slope on this is over 1 and then up m. And in our case, you know what I mean, m is larger than this, so this slope right here, how we have it, might be a slope of 2 or a slope of 3. So keep that in mind. Because then when we roll it like this, like what happens? You know what I mean, if we draw this in, this is going to be my m and this is going to be my 1. You know what I mean? So that's how we went from here to here. And so that's what we have. We have a jump of 1 over m. And then so I can start, you know, putting in that this is going to be m squared plus 1 squared. Square root that. That's going to be that side of that proportional triangle. And sweet. And then when we do this, you know what I mean, if I'm going to take this slope is the same. But the second I do this, I take it from like a vertical axis to a horizontal. What happened is the slope, you know, went from over 1 up m to up 1 over m. But it also changed sign, you know what I mean? So I got to be cautious about that. This slope is a positive slope. And when we do this, this slope is a downward slope. It's negative. So this slope is equal to m. This slope is equal to the slope perpendicular is equal to 1 divided by m with the sign change. So that's what I have here. So this slope is m on this triangle. When we flip it, when we turn it to a different axis by 90, you know, this is now perpendicular. So if I drew this line and this line, these lines would meet perpendicular. So that's also what's happening there. And this slope is going to be the inverse, but also with a sign change. So it's a negative 1 divided by m. Alright, hell yeah. So I think that was thorough. I don't know how to get better at making these math videos, but I thought this was pretty good, you know what I mean? At least just draw out what I wanted to do, go over it, and then, you know what I mean, talk my way through it. So thanks for joining me on this one. Booyah.